Hello everyone, welcome to today's class. This is Teacher Simon taking you through Probability and Statistics 1. This is paper 9709-53 for May, June 2025. And this is part 1 for questions 1 to 4. Question 1 is coming from coded data in statistics. They're saying for a set of 40 values of x, it is found that the summation of x minus k is equal to 836. Then the summation of x minus k, then bracket squared, is equal to 25,410.8, where k is a constant. And then part A, given that the mean of these 40 values is 124, find the value of k. Now, I want to take you through a process, and then I show you how this summation of x minus k is connected to the summation of x and then the mean, okay? Now, suppose I have x values, and then we say summation of x is equal to x1, then x2, x3, and many others, okay, up to, let's say, xn. Then we also have summation of x minus k. That means each value of x, you subtract a k, okay? So x2 also subtract a k, x3 also subtract a k, and then up to xn minus k. This one simply implies if I try to pull down the x's, I can have x1 plus x2 plus x3, then up to xn, then minus these k's. How many do you think they are? They are not 4, because you are seeing they are 4 here. I said, now here I have the 3 dots in here, meaning there are very many values there. You get it? So, but here I have xn, that means the x values are n. So, meaning we are going to subtract k n times. You see that? So there you have kn. But this simply implies that summation of x minus k is going to be equal to, what do we have here? It is this one. It is summation of x naught, so we have summation of x here, and then minus kn. So that is the connection. You see that? Now they give us the actual mean of 40 values. So if I divide all through by n, I have this one here, divide by n, summation of the values, then you divide by n, you will be getting what we call mean, okay? Then minus this kn divided by n, of course you get what? N. So meaning coded, this is coded mean. Okay, can come this side, and then we have this one here over n, then minus summation of x minus what? K. So this k is actually equal to actual mean, okay? Actual mean, because you are getting the original x values divided by, you are adding them, then you are dividing by how many they are, and then this one here is the coded mean, okay? This is how we do it. Now, what do we need to find? They told us to find the value of k. So k is going to be equal to the actual mean, okay? Mean was given as 124, also. Then minus, what is the coded mean? We shall get this one, then divide by the 40, okay? Look at what we are having here. So 836, then divide by 40. So altogether, what will be our k? 124, then minus 836 out of 40. We get 103.1. So that means the x values, they subtracted 103.1. Then part B, find the standard deviation of these 40 values of x. Now, you should know that standard deviation isn't affected by coding. Isn't affected by coding. Standard deviation and variance, actually, they are properties that prove this, but it's out of our scope in this paper. Okay, so I'm not going to do it. Okay, so that means if I have standard deviation which is equal to root of, then I use coded data, summation of x minus k out of n. Then here we have summation of x minus k out of n here, then the bracket squared. If you are using coded data here, even here you are using coded data. Okay, this one actually gives the same value when you say summation of, let's say, x squared out of n, then plus, it's a minus, summation of x out of n what squared. So you will get the same value. That's why I'm saying this is not affected by what? By coding. Now I'm going to take this one here because we are given coded data. So this one for the square, it is given as 25410.8. So we have 25410.8 divided by 40, then minus summation, this one here, the coded mean. So we have 836.0, then divided by 40, then brackets what? Squared. And then what do we get altogether? Square root of 25410.8 out of 40, then subtract, we have 836 out of 40, then we square that. So our answer becomes 14.1 to 3 significant figures. 3 significant figures. As simple as that. Question number 2. At a large college, all students who study science also study exactly one of art or drama or music. 20% of these students study art, 45% study drama, and 35% study music. But 3 students are selected at random from the students who study science. Find a probability that at least one of these students studies drama. Okay, now this is a binomial because n is fixed and all the outcomes are independent. So they are saying we find at least one of these students studies what? Drama. So let the random variable here represent those who study drama. So greater or equal, because at least means greater or equal. So this one can be, that means I'm going to have 1, 2, and 3. And so probability of x is equal to 1, x is equal to 2, and probability of x is equal to 3. But probability of x is equal to 0 is not considered. So that means I can say probability, this one is equal to 1 minus probability of x less than 1. That is the same as saying 1 minus probability of x is equal to what? To 0. So you have 1, then minus, what is our n is 3. What is our p? Those who study drama, that is 45%, so that is 0.45. So meaning q is going to be 1 minus this one, that is 0.55, not so 0.55. Then I will come to this and I say 3 combination 0. That means we have no success, and then the probability of getting the success here has to be to the power of 0, and then for the failure, then it has to be to the power of 3, only failures, right? Because when you add those 2 powers, you get the n here. Okay, now putting this in the calculator, what do we get? 1 minus, then we have 3 combination 0 is a 1. In fact, we are having 0.55 power 3, because even 0.45 power 0 is a 1. So we have 0.834, 0.834. That is to 3 significant figures. That is that. And then part B, 10 students are selected at random from the students who study science. Find a probability that more than 7 study art or music. Okay, even this one is a binomial. So if I say probability of x greater than 7, that means here we can take probability of x is equal to 8, then probability of x is equal to 9, and then probability of x is equal to what? To 10. You see that? Now here, our P, because they have said from those who study art or music. So art or music all means addition. So our P is going to be, you get for art, it is 20%, music 35. So when you add that one will be 55. So we shall get 0.2 plus the 0.35, which gives us 0.55. So that means Q is therefore going to be 0.45, and then our N is going to be 10. Okay, it's going to be 10. Then here we shall have 10 combination 8. Our success is 0.55. Then we shall put power 8, and then the failure is 0.45. We shall put a 2 such that when we add we get what? A 10. And then plus we shall have 10 combination 9, and then we have 0.55 power 9, then 0.45 power 1, and then 10 combination 10, then 0.55 power 10, then 0.45 is to the power of what? 0. So what do we get here? Altogether, I can get the answer. 10 combination 8 is the same as 10 combination 2. That is 10 times 9. That is 90 divided by 245. So this is 45. And then times 0.55 power 0.55 power 8. Then times 0.45 power 2. Then the next one is 10 combination 9. That is 10 times 0.55, then power 9, and then times 0.45, then to the power of 1, and then lastly 10 combination 10, that's a 1, 0.55 power 10, 55 power 10, and then 0.45 power 0, that's a 1. So we get 0.0996, 0.0996 to 3 significant figures. That is that. Question 3. A fair 6-sided dice with faces labeled 1 to 6 is thrown repeatedly until a 3 is obtained. So until, the moment they say until, that is a geometric what? Progression. So this, not a progression, it's a distribution, sorry. This is a geometric distribution. Why? N isn't fixed. You do the experiment until you get the result. Okay? The number of throws taken is denoted by the random variable of x. So what is the probability of x is equal to 8. So that means you are going to throw 8 times. That is when you get the success. So meaning the first 7 times you are failing, not so. So probability of x is equal to 8, then is going to be equal to q power 7 7 times you are failing, and then the last time you succeed. Okay, now what is our P? Our P is the probability of getting what? A success. So that is the probability of obtaining a 3. And a 3 is 1, then out of the what? The 6. Meaning our Q, 1 minus the P, or 1 minus the 1 over 6, it will be 5 over 6. So meaning we shall have 5 over 6 here to the power of 7, then times 1 over 6. So what becomes our answer? 5 power 7, then we divide by 6 power 8, because the other one is 6 power 7, then times 6 power 1, not so? And then we are going to have 0.0465. 0.0465 to 3 significant figures. That is that. Then part B, find the probability of x less than 9. Now in here we have you do the experiment. When you get the success, you stop, but when you fail, then you continue. So less than 9, we shall go up to 8. Okay, you are getting the success. It can be on the first, on the second, on the third, on the fourth, on the fifth, on the sixth, on the seventh, or on the 8th. This is 1, 2, 3, 4, 5, 6. Remaining with 2. 7, then 8. So for this one less than 9, we can take P, then this QP, Q squared P, Q cubed P, Q power 4, then P, Q power 5 P, Q power 6 P, Q power 7 P. You see that? All of these ones added together. But do you realize that there is one root that we have not taken into account? This one here, only the Q's. So since total probability is 1, then I will say 1 minus these Q's which are left. Okay, so probability of x less than 9 is going to be equal to 1 minus Q power 8. So this will be 1 minus our Q is 5 over 6, then we power it with the 8, and then our answer then becomes 1 minus, we can have 5 out of 6, then to the power of 8. That is 0.767. 767 to 3 significant figures. Okay, alternatively, if you want to take the other one that I mentioned that first, less than 9, you are going to have this P here, then plus QP, then plus Q squared P, then plus Q cubed P. The next one is Q power 4P. The next one is Q power 5P. The next one is Q power 6P. And then lastly, Q power 7P. So we put all of those and then we add them and we get the answer. So our P, remember, is 1 over 6. Then this one is 5 over 6 times 1 over 6. Then we have 5 over 6 squared times 1 over 6. 5 over 6 cubed times 1 over 6. 5 over 6 power 4 times 1 over 6. Then 5 over 6 power 5 times 1 over 6. Then 5 over 6 power 6 times 1 over 6. Then lastly 5 over 6 power 7 times 1 over 6. Okay, then we put all of these ones in the calculator and then we get the answer. So let's put everything in the calculator and then we see what we get. 1 out of 6, then plus, that will be 5 out of 6 squared, not so? The next one is going to be 5 squared out of, then 6 power 3. The next one is going to be 5 power 3, then out of 6 power 4. Then the next one is going to be 5 power 4. Then we divide by 6 power 5. Okay. Then the next one will be 5 power 5. Then we divide by 6 power. Let me first take off this, because I've seen that black box coming. So we are on 5 power 4. We have to go up to 5 power 7. So that one gives us that. Then we have 5 power 5 out of 6 power 6. Then 5 power 6. Then out of 6, then power 7. And then the next one is going to be 5 power 7 out of 6 power 8. I think that is where we end. You see that we get the same answer, 0.767. 0.767 to 3 significant figures. So by considering 1 minus this one, it is the simpler way. Then part B, find the probability that A3 is obtained for the second time before the 6th throw. Before the 6th throw. Now we are going to consider many here, okay? Number 1, it can be obtained on the second, okay? On the second throw. So we are having 1, 2, so you have a 3 here, and you also get a 3 here. Then on the third throw, because they say the second time, so that means the first time you are getting it, and then on the second time. So if you get it on the third throw, that means you have these 2 here, this one is here. So the 3 can be here, okay, or here. Are we there? It can be in the first one here, or on the second one here. All right. Then next, let's look at on the fourth throw. On the fourth throw, 1, 2, 3, 4, that is where we are having the 3. And they said before this, then that means we shall go up to the 5th. Then on the 5th throw, 1, 2, 3, 4, 5, the 3 is here. Now, here, you are having only 3s, okay? So I'm going to have our probability here. Probability is going to be equal to, here, you are having 1 over 6, the probability of getting the 3 here, then times also 1 over 6, not so? Times 1 over 6, that is the first one. So we are adding all of these ones together. And then here, out of these 2, we have only 1 success. So out of the 2, I have 1 success. So probability of obtaining a 3 is 1 over 6 power 1. And then 5 over 6 is power what? Is power 1. And then times the probability of obtaining a 3 here, which is 1 over 6. You see that? So I'm going to treat these as binomials. Now, if the 3 is obtained the second time on, let's say, the 4th throw, that means maybe you got it on the first one, or on the second one, or on the third one. In other words, you are having only one success here, and then the rest are failures. You get it? And then you can multiply by the number of times the experiment is done here. Okay, that's why we say this one is going to be, out of the 3, we are getting the success one time. Are we there? And the success, the probability of obtaining the success is 1/6. Then we shall put to the power of 1, and then we have 2 failures in there. Then after, we go to this one here, which is 1/6. You see that? And then lastly, we can have, out of these 4 times, okay, you are having only one success, and the probability of obtaining the success is 1/6, and then you are going to have 3 failures here. So 3 failures, we have 5/6, then to the power of 3. You see that? To the power of 3, and then we have 1/6. So like that. Now when we put everything in the calculator here, what do we get? 1/6 times 1/6, that is 1/36. Then we go to the next one. 2 combination 1 is a 2, then times, we have 5, then out of the 6's will be to the power of 3. Okay, then the next one, 3 combination 1 is a 3, then times, we can see 5 squared, then out of 6's there, I think they're going to be altogether, it is 6 to the power of 4. And then from there, the last one, we have 4 combination 1, that one is going to be a 4, then times, we have 5 cubed, and 5 cubed is the same as 125, and then 6's here, we have power 3, and then the other one, and then that one, so it is going to be to the power of 5. So like that. So all together, we are going to get 763, then out of 3888. But to 3 significant figures, this one will give us 0.196. 0.196 to 3 significant figures. As simple as that. Question 4 is coming from statistics. 84 people attempt a particular puzzle. The times taken in minutes to complete the puzzle are recorded. These times are represented in the cumulative frequency graph below. Okay, and then they are asking us to use the graph to estimate how many people took between 4 and 7.5 minutes to complete the puzzle. Between 4 and 7.5. Now, where is 4? So you go and look for the 4. It is here, and then you see where it meets the curve here. Then you read off the value this side. See that? So this value here, but again, we have to make this one dotted so that it doesn't interfere with the graph which was given there. Okay, and then we also go to 7.5, which is in the middle of 8 and 7. So this one comes here. Then from here we can go this side. Just there is also in the middle here. So then we also dot it. That is what we are having. Then we get the difference between the two, because they have said in between, right? So when you look at what we are having here, this has to be, if this is 60 and this is 70, equivalence of a small box here is what? Let us find out what the equivalence of a small box here is. So one small box here is equivalent to, they are adding 10 every now and then, but there are 5 small boxes in here. So this one is equivalent to 2. That means here we are having, this is 62, 64, 66, 68. Then in here it has to be 69, right? So 69, and then here it has to be 22, 24, 26. So 69 minus 26. We shall get 69 minus 26. And then that one gives us 43. As simple as that. Part B. On the grid below, draw a box and whisker plot to summarize the information in the cumulative frequency diagram. All right. Okay, so we need the lowest value. The lowest value. Remember, the box and whisker plot, in the box and whisker plot, we only plot 5 values. We need the lower quartile, which we always denote with Q1. We need median, okay, which we denote as Q2. Then we also need the upper quartile. We need the upper quartile. We denote it as Q3. And then lastly, we need the highest value. So we need the highest value. Okay, so we need to find the lowest value here. The lowest value, if we go back and check here, it has to be corresponding to the what? To these 2 where we're starting from, okay? So we shall have a 2. And then quartiles, the quartile is the number that divides the given distribution into 4 equal parts, right? So how many people do we have? There are 84. So we shall have a quarter of 84, okay? And of course this one is going to be 4 goes into 8 too, so that is 21. So the 21st value, then when we go to our graph here, we look for 21, okay? We look for 21. So you come to this one here. 21 is going to be just here in the middle of this. Then we come down here and we see what we get. So even this one, I'm going to make it dotted. This is our Q1. We denote it with a Q1 here. So when you look at this, it is going to be 3.2, 0.4, 0.6, 3.7. You see that? 3.7. So I'll write this as 3.7. And then median, that number that divides the given distribution into 2 equal parts. So a half of 84. Okay. This one is going to be 42. Yes. So the 42nd value. Then we go here and we look for 42. So 42 is just here, one small box above 40. And this one can be this 4 point what? 4.8 or 4.8 something. You get it? Yeah. It looks like it is beyond 4.8 by something very small. But I'm just going to put 4.8. Okay. So we shall come here and then we put our 4.8. Then how about the upper quartile is 3/4 of the 84. So this is 21, then times 3. 21 times 3, isn't that 63? So we have 63rd value. So we also look for it. 62, then 63 is just in the middle of these 2 here. Then we also go down this one here. Remember to make these lines dotted to be smart. Okay, so this one for the upper quartile, this is Q2, this is Q3. So this is 6.6. Yes, 3 small boxes. I think you can see them off the 6. 6.6. So right here, 6.6. Then the highest value, of course, you just come to this one here, which corresponds to this, okay? That is 12. Now, we draw our box and whisker plot. Remember, we must have a uniform. We must have a uniform scale here. Okay, so if this one is a 2, 4, 6, 8, 10, 12. Yeah. Oh, I can say this is 1, 2, 3, 4, 5, and then the rest. So we begin plotting. This is a 2. I'll draw this one here. 2. That is my lowest. The highest is 12. I'll draw here. Then after that, we have our median, which is 4.8. So we go 4 small boxes above 4, or on the right of the 4. That is the median. And then we have the lower quartile as 3.7. So I have to go 3. That will be 3.6. Then in the middle. So it will be here. And then the upper quartile is going to be, what did we get here? 6.6. Okay, so 3 small boxes on the right of 6. This is the one here. Then we connect the boxes like that. I mean, we connect the upper to the lower. So that is where the box is going to be. Okay. Then we get a line here that connects this to that, and also from here to there. So that is going to be our box and whisker plot. The start of the box is the lower quartile. Any line within the box is the median, and then the end of the box is the upper quartile. Then this side we have the lower and then the highest value. I mean, this one is the lowest value, then the highest value. So that is that. So this has been it for this first part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful, kindly like, share, and even subscribe. See you in the next videos.